You know the feeling, right? You're stuck at a red light, staring at a totally empty intersection, and you're just wondering, who designed this thing? Urban traffic can feel like this huge, chaotic, unsolvable puzzle. But what if the solution isn't more roads, but more intelligence? Let's dive in and see how.
I mean, really think. What if instead of just running on a dumb timer, a traffic light could actually see the traffic, understand what's happening, and make smart decisions in real time? That's the big idea we're going to explore today. An AI system designed to be the ultimate traffic conductor. So, we're going to put this digital traffic conductor through its paces. To see if it's really as smart as they say, we're going to throw 3 very different, very real-world challenges at it. A normal day, a sudden crisis, and, well, a critical equipment failure. Let's see how it holds up.
So, how does this thing think? Well, it's basically a 2-step process. First, it uses something called Kalman filters to make sense of all the chaos. It sees the real traffic situation by filtering out all the junk data from imperfect sensors. Then, once it has that crystal clear picture, its reinforcement learning brain decides the absolute best way to keep things moving. It's a really powerful loop. See clearly, then act wisely.
All right, test number 1 is all about stability. Can the system handle the normal, predictable, yet kind of messy flow of a typical day? This is the baseline, you know? If it can't get this right, then nothing else really matters. So here's the setup. A pretty standard 4-way intersection. Traffic is flowing pretty evenly from all directions. But here's the catch. The sensors counting the cars, they're not perfect. They've got an error margin of plus or minus 3 cars, which is actually super common in the real world. The AI has to work with this fuzzy, not quite right data.
And check this out. This is the AI's brain at work. On the left, you've got the raw, noisy data coming from the sensors. It's all over the place, right? But look at the right. That's the AI's corrected estimate. It's smoothed out all the errors and figured out that traffic is actually really balanced, with about 11 cars in each direction. It found the truth hidden in all that noise.
And because the AI has an accurate picture of what's really going on, its decision is just perfectly logical. It gives about a quarter of the green light time to each of the 4 directions. No guesswork, no wasted time. See, it's simple. Good data leads to good decisions.
The outcome is pretty much exactly what you'd hope for. Delays are kept to an absolute minimum, and the traffic flow is smooth, efficient. So, test 1 is a definite pass. The system has proved it's stable and reliable for the everyday grind. But let's throw it a curveball now.
Okay, for our second test, we're going to simulate a sudden shock to the system. You know, the kind of thing that creates instant chaos and sends traffic nightmares rippling through the city. This is exactly where a simple timer-based system would just completely fall apart. I want you to picture this. A big concert or a football game just ended, and all of a sudden, one road leading to our intersection gets slammed with a massive surge of cars. The line of waiting vehicles just explodes, going from maybe 10 cars to 40 in just a few minutes. The system has to see this coming and react fast.
But here's the problem. The physical sensors are literally overwhelmed. With so many cars packed together, they can't actually see them all. It's a problem called occlusion. So they're only reporting 30 cars. But the AI, using its own internal model, it corrects for that error. It realizes the queue is way worse and estimates it's actually around 38 cars. It sees the true scale of the problem when the hardware can't.
So, armed with this much better data, the AI takes decisive action. It just rips up the normal light cycle and immediately gives an extra 20 seconds of green light to that one super congested road. It's basically performing traffic triage, tackling the most critical problem first.
And it works. The massive queue gets cleared out before it can cause a bigger, cascading traffic jam that messes up the whole area. The system didn't just manage the problem, it totally solved it. So, test 2 is another pass. This thing is highly adaptive under pressure. But what about the ultimate test?
Okay, for our final and most difficult test, we're going to break the system's eyes. What happens when the AI is being fed information that is completely fundamentally wrong? Can it actually reason its way out of being deceived? Let's find out.
Here's the scenario. A sensor on one of the roads completely dies. It gets stuck and it just reports 0 cars, over and over. Meanwhile, in the real world, a line of 15 cars is quietly building up, totally invisible to the system's main sensors. A standard system would just starve this lane of a green light forever. Now this is incredible. The AI sees that 0 reading coming from the north.
But its internal model basically says, hang on, based on the time of day and what usually happens here, a reading of 0 is extremely unlikely. I don't trust it. So the system effectively ignores the bad data and relies on its own prediction, estimating that, yeah, there are probably about 15 cars waiting there.
And because the AI wasn't fooled, its actions stay correct. It gives green light time to that lane with the invisible queue, along with the other busy lanes, all while ignoring that false 0. It has successfully navigated a critical hardware failure without even skipping a beat.
So test 3 is a resounding pass. This proves the system is more than just adaptive. It's resilient. It can handle and literally reason its way through real-world equipment failures, which is just absolutely critical for any system we're going to put in our cities.
So, after running this gauntlet of 3 increasingly difficult challenges, what's the final verdict on our AI traffic conductor? Let's break down its proven strengths.
Well, the report card is pretty much stellar. We proved its stability in that first test, where it handled a normal day perfectly. We proved its adaptivity in the second test, where it expertly managed that sudden traffic surge. And finally, we proved its resilience in the third test, where it intelligently overcame a complete sensor failure. It's a robust, all-around solution.
And this leaves us with a really fascinating final thought. We've just seen an AI master the crazy, dynamic world of a single intersection. So if it can do that, what's the next step? Coordinating an entire corridor of traffic lights? Managing citywide traffic patterns during an emergency? The possibilities here are as wide as the open road ahead.